A very warm welcome, ladies and gentlemen, to both the conference and to the afternoon session, specifically on smart energy. Sorry for that. Smart energy for energy union. So a session very specifically dedicated to material innovation in the field of energy. I'm honored to be the chair of this session today. My name is Martin Winter. I'm from CEFIC, from Brussels, from the European Chemical Industry Association. And in that role, I'm supporting the chemical sector to drive the innovation agenda towards the stakeholders we have in Brussels. For example, with the European funding instruments like the SPIRE Public-Private Partnership or the Factories of the Future, PPP. Of course, a very welcome also to our 5 distinguished speakers we have today. I think we have a very, very powerful panel. So we have 2 speakers from industry. We have represented the steel dinosaur, as we learned in the previous panel session. We have the power sector from EDF. We have a speaker from academia. We have a speaker from an association dealing with energy innovation and materials. And I'm very, very proud that we have also a very well-known speaker from SME actually, or startup, depending how you look upon, to give us his perspective, especially from the startup point of view. So various perspectives that looks for a very, very exciting session. So I would like to encourage you also to use this Slido tool. Some of you might have experienced this already in the previous panel session. I think that works quite nicely. Just go to your browser, go to slido.com, and very important that you choose the right room. REinEU room B, this is room B, and then you can have the possibility to type in your questions. And I propose the following. We will go through all the 5 presentations in the beginning, and at the end of our session we will bring then up your questions in a kind of panel setup. Okay, well, ladies and gentlemen, if we talk about smart energy for energy union, actually to put it in the political context, it's one of the priorities of our European Commission's President Juncker, one of the 10 priorities, to be more precise, energy union and climate. And if we're thinking about decarbonizing our industry, so having a more energy efficient industry in our manufacturing plants, having a decarbonization of transport, for example, going to more electromobility, going to more energy efficient buildings, going to renewable energy, what the Germans call Energiewende, energy transition, using solar and wind power in our power plants as of today. And the storage system associated together without advanced materials, I think we can all agree it would absolutely not possible. So innovation in advanced materials and nanotechnologies is absolutely important. Do not want to waste any more time. We will start now with the first speaker. I'm very glad to have Samir Boujaber here. Essentially, he's a knowledge group leader in Tata Steel, so one of the industrial dinosaurs. He has a PhD in construction management. He's also chairman of the European Steel Technology Platform Construction in ESTEP, which is a steel technology platform. And I'm looking forward to his presentation where he surely will share some ideas how innovative the steel sector is today and how steel and construction materials can make buildings much more energy efficient and also what I would like to call energy intelligent. So Samir, the floor is up to you. I'll try to see if you can have it in your hand. I'll try with that one first. Here. Hello? Okay, it should work, I guess. Okay. Ladies and gentlemen, good afternoon. First, I would like to thank you, Mr. Chairman, for the kind and generous introduction. I also would like to thank the organizing committee for the invitation and giving me the opportunity to speak to you on behalf of the sector I represent. And I'm also glad to be in this beautiful city with you today. I've got a few slides on
trying to position it as our journey towards energy efficiency. My slides will cover first the role of steel in construction. Although I'm from the steel industry, I'm going to focus on the construction sector, and then touching on the future trends and trends and challenges, and also a couple of examples on technologies and how we're dealing with that, and then hopefully summarizing and with 1 or 2 points on recommendations how we can move forward. Okay, the steel in the construction sector, obviously it would be quite strange to have someone from the steel industry talking to you without talking about the credential of the steel as a material. We've heard earlier the steel industry being a dinosaur, that's true, but in the context of the conference, it is a highly efficient and very industrialized industry, and that goes back to centuries back. As you can see from the picture, steel plays an active role in our daily lives. I'm sure all of us today coming today that contributed in a way or another, either through transport or construction, buildings or packaging or energy or whatever. It is also a highly, very recyclable material, so in terms of circular economy, it's a pretty good stuff. Again, homing in on construction, it's a very versatile product, versatile material. It allows architects and engineers to express themselves with the design, and because some shapes are only achievable in a way with steel, its way to strength ratio pretty good. Again, going back on the context of the conference, it's a material that lends itself to off-site construction, where we can industrialize all the processes and just leave in the activities on site just for the assembly. 1 or 2 points on the construction market. Steel, the word production of steel, more than half of that goes into construction. So you can see the role the material plays in this sector across all the segments of construction. In Europe, in the EU 28, this is estimated to 40%, and it's no reason for it not to carry on as long as we maintain our eyes on the ball and keep innovating and coming up with new products and new solutions. The construction market itself is a very important sector for Europe in terms of its contribution to the GDP, but also the employment. It's a big employer, the sector. However, it is represented by a large number of SMEs, and that has a knock-on effect on the innovation and how the sector can move forward. Because most SMEs are talking about less than 10, with little or no R&D, but also challenges in implementing innovation. And we've seen in the earlier session in the plenary how the Commission is trying to enable that. Okay, having looked at the steel and the construction sector, I would like to move on to the trends. The sector is basically faced with challenges associated with high rising population, expansion of urban and mega cities, global warming, the effective use of resources, aging population and the role we can play in contributing to the societal issues, and how also we can master CO2. The main driver is we can see now a trend towards megacities and all the stuff that is coming around it in terms of resources, transport, and how we can manage and feed all those people living in those cities. You can see from the picture there, we've got the shift towards digitalization in the construction sector. It's a new way of working in the construction. Having said new, REinEU in terms of a collaborative way of working. It has always been there, but everyone working in their own patch with IT and softwares. But now there is a trend where we working together through BIM. A lot of pressures on modern method of construction, and that's very positive. Although they are challenges, we see them more as opportunities. And modern method of construction is it's a good opportunity for us, how we can reindustrialize the sector. And basically, we're not taking jobs out of the sites, just we're moving them to a factory environment where we can control the processes, the products, addressing health and safety issues. But also, it's an environment where we can introduce quickly innovation because it's in a very controlled environment. In the steel sector, we work in and addressing all those issues from the smart cities and what those means and what solutions we can develop in those contexts. We're looking at emerging technologies, how we can embed those into products and solutions, such as 3D printing and robotics and so on. And of course, the circular economy, how we can make sure we're not wasting our resources. All right, having had a kind of a helicopter view, I would like to home in on exactly what the market is, what the market wants, what the end user, what the customer wants. Basically, what we're looking for, what the market is looking for is kind of regulatory framework where all the sector, all the various stakeholders working within the same framework, not we have different suppliers, designers, consultants, contractors working in a different regulatory framework. More importantly, the end user is looking for affordable, and I stress on the word affordable because there are some technologies out there, but they're not yet affordable in that sense. Affordable, low to zero carbon solutions and technologies, which will help us to minimize the energy in use, but also, why not the energy generation, and of course not forgetting the comfort of the end user. I'd like also to stress it's not just about carbon. I mean the modern method of construction and how we deliver those solutions to sites are equally important. How we make them off-site, how we assemble them, but also their life cycle. So it's not just job done, it's there and that's it, it's someone else's issue. So the ease of delivery, the assembly on site, and also the scalability, how we can build on the existing assets. All right. In terms of technologies, I've picked the word journey, and yes, we are on a journey, and I think we're happy to be on a journey, and we don't want that journey to end. The reason for that is we would like to evolve and innovate continuously, and it's not basically a line there. Once we cross that line, that's it. I mean, we can see today's problems the European or the Western world is faced with, since we can see a shift towards the eastern part of the world. So it's a journey, and we're happy. It doesn't end, so we keep innovating. What I would like to say through this picture is basically buildings in the past. There were, or the expectations from a building was purely something to protect us from the element, from the rain and the weather out there. It's something like a roof over our heads. Those days are gone. Now the expectation from a building is we want that building to contribute and do something. So we moved on to the energy efficiency. And to some extent, we've addressed those issues, and we can consider most of the buildings are now efficient. We have a regulatory framework in place, how we can address that, and that also how we can monitor that. And that also through developing new products and solutions, looking at the interfaces between elements, looking at the construction on site, the assembly on site, and so on. But also the interface of the user with the building and educating and also spending a bit of time on education there, how we can run and manage the building. Having got to that point, we moved on into, okay, what else can we expect? Then we moved on onto the generation. Why can't we use our buildings to generate power and be self-sufficient? And why not even sell to the grid? Buildings are an asset. I mean, they can be seen, and in fact, in our development, we see them as a power station. It's something that can generate its own power. And now, in terms of technologies and research and activities and product development, we are looking at solutions for the generation. Again, I said the journey, we don't want to stop that. We're looking forward. What do we expect? So we put in scenarios in terms of what's next, what we would expect from the buildings in the future. And again, there is some research into that direction. A couple of solutions, and those are all commercial products. I mean, we managed to activate the roof, so we have solutions for the roof. Either we through PVs installed on a frame or installed directly on the roof skin, but also we can have PVs almost glued on some products, like in that case the CalZip. We've got solutions for active floors, how we can drag in the air from outside, especially in commercial buildings, and use the thermal mass of the floor. But also we have running some pipes in the floor. Beyond that, we're also looking at the skin, how we can activate the entire skin of the building, and that's the facade as well as the roof. Again, we have commercial products there, and the picture completely on this side, that is currently a demonstration project in Spain, and it's a composite panel that captures heat for cooling and heating of the building. What I would like to say on the line below is we're not just concentrating on developing those technologies, but also we're looking at how we can make them, how we can introduce modern method of construction, how we can make buildings adaptable, how we can enable the building fabric to generate, capture, and also store energy and so on. Gosh, I've got 2 minutes. All right, got the last 1 minute or two. In terms of recommendations, first I would like to summarize. What do we really expect from the future of the built environment? Of course, I mean, we're looking at how we can digitalize the building, how we can make the building something that works on its own. And that's not just through the design or the construction phase, it's through the life cycle of the building. And there are tools out there, and the sector has started really working into that direction. But also that will help us in the life cycle of the building, how the building can run itself. Of course, safety is very important, since we're going into different ways of working or industrialized construction and so on. We'll be looking for new skills, how we can assemble them on site, and the implication on safety. So safety is paramount for us. Also the automated buildings. Why not buildings cannot talk to one another, run their own facility management, tell us exactly if there is a need to heat a room or to cool a room or to replace something or another. And of course, that's the theme of this conference, is how we can make buildings as power stations, i.e. Self-sufficient in terms of energy, but also contributing to the grid and to the neighborhood. In that case, we will be replacing the building from just a roof over our heads to an asset. In terms of recommendations, I've got a slide on technologies really needed. So for us to achieve those targets and those challenges, we'll be looking at working on digital platforms, embedding smart and disruptive technologies into the building to help us have a better asset. Also, we need to open up a little bit our eyes and look at the composite construction, composite materials. What other materials are out there that we can work together with? This is my last slide, and fortunately I might have to spend a minute on it. I think the other issue is, okay, we deal in all those things, but we need to make sure, in terms of policies and so on, what do we need to do to make them happen? What we call, and there was an interesting question earlier on the valley, on the Valley of Death. What we need to do is to bridge that, is to make sure we have policies in place, legislations in place to help us address that valley and bridge it. I mean, now with the new, what we call the digital natives and the startups and so on, there are so many good ideas on the lower end of the TRL. But then between that and being a commercial product, there is a huge gap. And we need some support how we can bridge that, take those ideas, those startups to make them a success. In our company, we already work in that direction, but we really will be keen to get some wider support, because it's not something down to one sector or one company or that goes with that is the open innovation. I mean, there are loads of guys out there doing good jobs. Why can't we get those contributing into the mainstream of research and taking those ideas and having instruments in place to take them across the valley? Key performance indicators. Why not having how we can measure buildings or assets? So not just on energy, but on a host of other things. And not necessarily you've got to satisfy this or you fail, but at least we know, so we can measure our performance and we know where we stand. Another point is to encourage innovation. Is we should not be scared of that. We should be encouraging and rewarding that. And what we call is to reward dare to try. So if someone has got an idea, why don't we try it? If we fail, that's fine, yeah. But let's reward that. Let's encourage trying it and so on. Open building sourcing, again, that will help us with innovation, because then we can have a host of products and solutions and technologies out there that they can plug in together. So we don't need to get products just from one supplier or two or three suppliers. So if we have an open building, I mean, you can see it in the IT sector, you can buy any chip for your computer from wherever you want. De-risking investment, I think we've touched on that. I heard some discussion earlier. And of course, it goes without saying, since we're getting into a new phase, we need to make sure education and training are up to date. And I've been careful with choosing the word soft legislation. We don't want legislations that will hinder take-up of technologies and so on. We need some legislation that will help us and try to take them across the valley. Thank you. Thank you very much.
So thanks a lot, Mr. Boujaber, for this very nice insight into the innovation in the steel sector. I pretty much also like your view that traditional steel and materials technology more and more is emerging with digital technologies in the construction sector. So I would like to welcome the next speaker in our panel, Juraj Kubica. He has a PhD degree in power engineering from the Slovak University of Technology, and actually his main interest of his research include decentralized power generation in renewable energy sources, mainly from biomass and solar cells. I should also mention that he is working as a senior advisor at the Office of the Deputy Prime Minister for Investments and Informatization here in Slovakia. And I think his presentation has been co-developed by Professor Janicek. I think he's also somewhere in the auditorium, which he works as the director of the Institute of Power and Applied Electrical Engineering at the Faculty of Electrical Engineering Information Technology here in Bratislava. So, Mr. Kubica, the floor is all yours. Looking forward for your views on distributed energy generation. Is it a threat or chance for current energy industries? Just let me encourage you to use Slido to drop some of your questions if you have.
Thank you very much for the introduction. Well, ladies and gentlemen, my presentation is a very bit different than the others because the rest of speakers is mostly from chemical industry background, while I'm also in the past from chemical industry, but now I work in electrical engineering faculty and also in the government. So I'm going to say a few words about energy flows, because energy and material flows are in the background of all the development we are talking about. When we look down, it's all about material and energy flows. Then, what are the opportunities for renewables and for distributed energy systems? Of course, when we look for the new development of materials and technologies in power engineering, this is the topic which we must consider. And one of the future disruptive technologies, I don't like this word that much, but when we talk about disruptive technologies, then distributed generation is definitely one of those, because when something has to change the future, that's the conflict between the centralized and distributed power generation systems. And finally, some expectations about energy for Europe and who will be winners and who will be losers of all of this. Of course, we have to start with something big. So to introduce the topic, the energy as a commodity, not as a physical property, but as a commodity, is necessary for sustaining of our standard of life. We all know that, for example, every human in society now is using about 70 times more power than what's the power of human strength. It looks like everybody of us has 70 invisible people working behind us just to sustain the light, the elevators, the cars, the trains, and all the systems we use in our society. But where to get all of this? Well, we use different sources, mostly non-renewable fossil sources, but also some renewables. When this is example of Slovakia, I deliberately used the power generation in Slovak Republic. When we look in this graph, we can see that consumption is, here I have laser. The consumption is mostly straight line over for more than 30 years. Since the late 1980s, the power consumption in this country has changed very little. We can see some bump in a few years here. That was during the collapse of socialism in my country, and in these years power has declined because many companies has closed down. Also, the great crisis in 2009 has meant, or we can see this in graph only as a slight bump, something going down. On the other side, the generation has been going up and down in the past quite wildly. In some years, when we have been operating more reactors, nuclear reactors, we have been exporting country. Then when we closed down the oldest reactors in V1 nuclear power plant, we became a slight importers, but only slightly. But let's look back in the Europe. This is the energy flow in total European situation. What are the imports? What are the local production? We can see that practically 1/2 of energy for Europe is imported. The other half is produced locally from local sources in European Union. But this is not very good for Europe, of course, especially for our industry, because all this energy which must be imported, mostly from Russia and some part from Norway, all this imported energy must be paid for. And our industry has to pay for this, and finally some customers has to pay for this. If we would be able to build or to produce more energy from local sources, of course, it would be much better even for our economy, not to mention economies of other countries. And the outline for the future. Oh, well, this is statistics for last practically how many, 20-something years, since late 1990s. Here, the Kyoto Protocol in 1997 has been established, built. And we can see that some sources has been growing steadily, especially wind energy has been growing very steadily for all the time. Later, after 2007, 2008, also photovoltaic systems has started to climb up the ladder. But another strong source, which is discussed a lot in Europe, is nuclear energy, and we can see that even when there has been some growth, finally more reactors has been shut down than how many has been turned on. It means that nuclear industry in Europe is in decline, even if we are talking about nuclear renaissance or other new words. Is this good? Is this bad? It's a matter of discussion, but the situation is showing that the nuclear energy is declining. Also, when we look for the last year more precisely, this is from the year 2015, we can see that the most growth of new sources is in wind energy sector and photovoltaics. When we look for sources which has been shut down, most sources are in coal and also natural gas and fossil oil, also some nuclear. In these sectors, no or very few sources has been put online. What is interesting is coal, actually, because yes, 2 times more sources has been shut down than has been put on, but still, even in 2015, 4.7 gigawatts of new coal power plants has been established in the European Union. That's not very good when we want to keep promises for climate change. And one other graph, which is showing the connection of new sources by countries, photovoltaic energy sources by countries. The last column is showing national renewable energy action plans, and even in 2013 we surpassed what we have promised to get her. We can see that in years after 2005 up to 2000, let's say 2010, the growth has been very small, but then it exploded, and now it's slowing down the addition of new capacity in photovoltaics. But still, we can see some very rapidly growing countries. For example, in last 3 years, the United Kingdom, which is unlikely representative in this situation, but even United Kingdom is building new photovoltaic systems in their soil. Of course, the most capacity is in Germany. But, well, there I have been showing a few graphs about the situation in the past and how it has been emerging. Now let's look for something different. The components of consumer price here in Slovak Republic. Those data are showing what we are paying in the bills for electricity in Slovakia. And I think that quite similar data are from neighbor countries also. The power generation itself, the price of electricity for power plant, for example, Slovenské elektrárne, as the main producer of electricity in Slovakia, takes only about 36% of the total. It means that 1/3 of price we are paying in our bills is for the electricity itself, and the rest, what's the rest? Let's take a look. 1/4, 26%, is for distribution. Well, it means that somebody has to take care about the power transformers, about the power lines in the distribution region, and this is normal. We have to pay for somebody to take care of these technologies. Another part are distribution losses, for example, because some energy is lost during the transport from power plant or from the transmission network to the consumer. So those losses are paid as a 6% of the final price. For example, we are also paying for transmission system. Oh, sorry, this is not in English. Transmission system, which means the high voltage, the highest voltage grid network is also part of the price, but only about 4%. For example, suppliers, the marketers who are selling the electricity or brokers of this selling are being paid less than 5%, this 5.78%. But some large portion of the total, this tariff for system operation, which makes 16% of the total, this is quite interesting part, because in this 16% of the total, we are paying for support for renewable energy sources. We are paying this part. Then we are paying also for cogeneration in a highly combined generation of electricity and heat, and also some tariffs for support of coal power plants in Slovakia, because we have a large coal power plant which is using local coal from local mines, and these miners are using support from public sources because it's not economical to use this coal. So another part is paid to them. If we want to build some new power market, we must find some solution how to support new sources like renewables, how to phase out old sources like coal power plants, and to sustain a good energy system while also establishing something like a market. The electricity is on one hand a commodity which must be brokered in power markets, but on the other side, electricity is also kind of a human right. Everybody should have access to power, especially electrical power, and how to find a good compromise between social service and the market. This is one of tasks for European Commission and all national regulators, how to find this. Okay, I'm almost in the end of my presentation. I will just mention now that our university is directly involved in two interesting projects. The National Center for Research and Application of Renewable Energy Sources. This is project where different faculties with different backgrounds from chemical industry, mechanical industry, building industry, and electrical engineering also are working together to give to the market some expertise about renewable energy sources and their integration in the power system and in industry. This is some kind of bridge, as the speaker before me has been talking, how to go through this valley between academic research and application in practice. So this national center is working how to find a way how to help. And we have also this another competence center for new materials, advanced technologies, and power engineering. And this is even larger project, also supported by money from European, what's the correct name? European Research and Development Funds. Here we are working together with industrial partners to find new materials, for example, for nuclear power technologies or for renewable energy sources like new blades for wind power or new materials for photovoltaic systems. Also, this is a way how to reach to the other industrial partners in the industry. Okay, and I'm ahead of my time, so thank you for your attention. And I have a few spare slides, but I think I will not show them now. There's some photos from our laboratories. Thank you.
Thanks a lot, Mr. Kubica. I think Kubica is also the name of a Formula One driver, if I'm not mistaken, so very excellent. Very, very nice presentation, combining different aspects of power economics, social aspects, and statistics. And I think it's also an excellent bridge to our next speaker, Mr. Didier Noël. Actually, he is a senior scientist in EDF, Électricité de France, one of the largest energy power companies in Europe, I guess, if I'm not mistaken, where he works already for more than 35 years in the R&D division in materials and chemistry for energy and also quite a couple of years, 10 years if I'm not mistaken, in nanotechnology. And I should mention he's inventor and co-inventor of 9 international patents, an author of more than 80 publications, and also editor and co-editor of several books in the field. And I'm very much looking forward to receive your presentation, the view from a power company, which fits very well with the previous presentation. And I think it must be very challenging for a company like yours. Selling and operating of large power plants is not anymore the business model. It moves, I think, much more to more service-oriented business models. So really looking forward to receive your presentation. The floor is yours. Thank you.
Okay, thank you, Mr. Chairman. I would like to give you a very quick talk about what we do with nanomaterials at EDF for energy. So here is a synopsis. I will quickly present EDF and present some examples of applications of nanomaterials we are studying at EDF and then reach the conclusion. EDF is a worldwide group. It has 160,000 employees. We are in 19 countries and mainly rooted in Europe, France, UK, Italy, Poland, Belgium, but also we are present in high-growth countries. We cover all the business chain, from power generation to transmission and delivery, trading, and energy service. And our energy mix covers the entire range of generating technologies. Mainly it is nuclear, as you can see here. 75% of our generation is nuclear, but we have also more than 10% of renewable. And that's why we have quite a specific point in Europe. We have more than 85% of our energy that is already decarbonized. It's very specific. And we have a strong R&D, more than 2,100 people settled in 10 R&D centers, among which 7 are in Europe, not only France, but Poland, Germany, Italy, and UK. And our priorities are written here, and it is, of course, to prepare the future. That means that we need a zero carbon production mix, new energy service for clients, and pave the way for electrical systems of the future. I would like to emphasize that, of course, we work on nuclear subjects. It's important for us. But more than 60% of our budget is on non-nuclear budget, like smart grid, storage, renewable energy, mobility, and smart cities. Now, what about nanomaterials for energy? We know for a long time that nanomaterials also promise numerous promise for energy, but in the same time there is very numerous and technical and economic uncertainties. And the question we had was, which are the most relevant innovations for electric energy and which are the best applications? Knowing that EDF does not sell objects, but mainly an energetic service. And to answer to this question, we launched several years ago a project, R&D project, to identify and assess the best innovations and make them available. So we found very numerous materials properties that could be enhanced by nanotechnology and that are relevant for the energy sector. Of course, mechanical properties, where you can increase the strength, the wear, the friction behavior, the creep, the radiation resistance, and so on, by nanostructuration of the material. And it is very interesting for material and energy efficiency. But you can also manipulate the thermal properties, electrical properties, and hydrophobic properties with very surprising applications for enhancing the heat transfer. I will speak of them. Now, we found that most of the activity sectors of our job at EDF and for energy were concerned by nanomaterials. We find application in electricity production, efficient material for power plants, heat transfer enhanced, photovoltaics, fuel cells, energy conversion. We are interested in heat pumps without mechanical part, using thermoelectric, and system integration. We need storage. Renewable energy are intermittent, and this intermittency needs a strong development of storage and power transmission and smart sensors. Now I will try to show you some examples, not many, but few one, where we find some interesting perspectives. Hydrophobic surface could be used for heat transfer enhancement. We know for a long time that when a drop is put on the surface, it can spread on. In that case, it is hydrophilic. But if it doesn't spread, it is hydrophobic. And the degree of hydrophobicity could be characterized by what we call the drop angle. That is the angle between the surface and the tangent to the drop. For several years, scientific people are interested in what we call the lotus effect. It's only high hydrophobic behavior that could be obtained by a kind of nanostructuring the surface with submicronic structuration of the topology. It allows to the drops to not to touch the surface, but to roll on the top of the pillars. And one interesting application could be to enhance the steam condensation process. Normally, this process occurs with what we call steam film-wise regime. That means the film covers all the surface because it is hydrophilic. And it is not a very effective, efficient process. If you can switch to a drop-wise condensation, that means you have a hydrophobic surface and so you have no film, then you increase considerably the heat transfer for the condensation step. But you need for that hydrophobic surface. Then we studied several kind of surface, and finally we built some loop which had conditions representative of nuclear power plant steam. It's quite height, about 2 meters, 3 meters high, and 2 meters long, and there is about 35 tubes in it. And on this condenser mockup, we demonstrate that we can gain about 30% of the whole overall heat transfer. And that is very interesting. I just mentioned that this subject is also taken into an European project, H2030, named matching, but on other solution, and EDF belongs to that with other companies. So it's a powerful tool for energy efficiency, not only for condenser in power plants, but we feel that every energy industry that has energy management could benefit of this kind of technology. Heat exchanger, condenser, heat pumps, refrigeration industry, and so on. But it's not so easy because the main question is the lifetime. When you have a condenser, you don't need to change your tubes or the surface each year, and you need really a very long durability. The second question is a way to scale up the industrial process. We are working on that. We have good hopes, and that could be things that could be shared at the European level with much benefit for each other. Another question we studied is fuel cells. I remind that fuel cells react hydrogen and oxygen on electrodes in order to produce heat, water, and power. And we take interest here at high temperature fuel cells that works about 6 to 1000 degrees. The need is to decrease the operating temperature in order to increase the lifetime and decrease the cost with best less expensive materials. But to do that, you had to improve the conductive properties of the materials in order to operate to lower temperature. We tried to perform that using nano-engineering of electrodes. It's more or less a kind of impregnation of electrodes by nickelets nanoparticles. That's not so easy, very numerous parameters, but at the end, we demonstrated that you can reduce by a factor 10 the conductivity, you can increase by a factor 10 the conductivity of the cathode. In that case, it was on an SOFC, that means anionic conduction cathode, and applied to the whole cell, it gave a benefit of 10% of increase of the cell power. It's not negligible, it's quite important. And today we are trying to extend the process to protononic conductors that will allow to operate at lower temperatures. And of course, to scale up it to industrial size cells in economic conditions. The last subject is micro-nano sensors. They are coming. They open the door to very little power needed, and it will allow long-lasting or complete energy autonomy. The interest is, of course, that probably the sensors will be low cost, of course, extended autonomy, and wireless. And the main reason for our interest that the implementation would be probably much cheaper than the sensors using hard wiring and with numerous networks. So we studied this area and tried to demonstrate that the passive sensors, which were interrogated by remote radar sensing, were operating in industrial environment. The question is not easy because electromagnetic environment in industrial systems could be very complex, and we were not sure that could be operating. The case studied here were pressure measurement on taps for power plants. These taps are not small taps as in your bathroom, but maybe 2 or 3 meters height, so it is big taps. And finally, we demonstrate that this was absolutely possible to make remote sensing in industrial environment. Here you have a kind of package sensor. It's not really micro, but very small. And it is the environment where we perform the test. And the status today is to master the packaging of the sensors. So time is coming out. We have studied many other subjects, but I have no time to describe them. Just to mention corrosion protection using nanofilms made by sol-gel process that could probably give a big benefit to protect some kind of stainless steel with stainless alloy. We developed for storage, electric storage, a membrane using ceramic nanofibers with much better conductivity and mechanical properties. It was for an aqueous lithium air battery that we feel to be a key for the future. And we are also working on thermoelectric material for heat pumps on some materials which seems very promising, not yet giving good properties, but that could be a good answer for the future. At last, my conclusions is that I have tried to show you that nanomaterials have really promise for the smart energy industry, that EDF is implied and develop a lot of innovations. And as a message, among technologies that we feel of importance, storage for mobility mobility on one side, but also storage for energy networks. The energy networks means new renewable energy, but also system services. The improvement of thermal transfer with super hydrophoby will benefit a lot. The key of autonomous question of autonomous sensors, and I don't speak of that, but innovative manufacturing and particularly additive manufacturing. We feel that it could be of importance and to develop. I thank you for your attention. At last, I just want to mention that if people is interested to have much more information, there is, I have written a chapter on this R&D, and it will very soon published in a book named Nanotechnology for Energy Sustainability. I thank you for your attention.
Thank you, Mr. Noel, for your insight into a lot of R&D projects ongoing in your company. I was quite impressed with the figure that actually 60% of your R&D budget goes in non-nuclear. It's very interesting. So I'm happy to introduce the next speaker of our panel. It will be Fabrice Dassin. He's actually managing director of the EMIRI Association. He holds a diploma and PhD in chemistry from University of Liège in Belgium. And Fabrice joined Umicore in 2008 as Innovation Project Manager, and since 2012 he's part of the Brussels-based team of Umicore Governmental Affairs, focusing mostly on energy materials, and as the director and father, I can say, of the EMIRI Association, of the godfather of the EMIRI Association. He will tell us more about EMIRI and the priorities within your association. Thank you to have you here. And maybe I'd like to encourage you again to use the Slido tool to ask some questions. So please, because we have not received a lot of questions, so please feel free to use the digital equipment. Type in slido.com in your mobile phone, and the room B, there you can drop your question.
Thank you, Martin. A good start. Okay. It will be my pleasure today to give you a talk which is maybe more focused on deindustrialization, reindustrialization, or in general industrialization, because it's actually the main topic of this conference. So I will give you a presentation which is around two pillars. The first one is the trends that we see in the industry of materials in the field of energy, and more specifically the field of renewable energy, and the impact it has on our industry, and then maybe a few slides on the proposed actions that we see in the field of Europe and in the field of European affairs in order to further manufacture materials still in Europe. I'm coming from the EMIRI Association, which stands for Energy Materials Industrial Research Initiative. And as you can see, actually, it's not a business club or an academic club. It's a club of everyone who wants to play the game. So it's an industry community coming together. It's supported by research and technology organizations, whether it's an RTO, whether it's an academic partner, and also some associations are bringing the expertise. I'm very happy, for example, to say that we have CEFIC, which is more business-oriented, and we have other associations which are maybe more on the academic side. So there's no gate to enter. As long as you are playing the game of energy and materials, of course you are welcome to join the association and try to influence with us the policies in Brussels. In terms of energy technologies that we look at from the point of view of materials, you can see that it's PV, CSP, energy storage, wind and marine, energy efficiency and decarbonization. So we don't want to leave anyone out. It's not a PV association or a wind association. I'm not going to say that we are completely technology neutral, because some technologies have a better future than others, but we look at all technologies from the point of view of the materials. So looking at the topic of reindustrialization, what we believe for us, for the association, is that if we want to reindustrialize Europe, we need to do it by looking at all the pillars of sustainability, so the climate or the environmental pillar, the industry pillar. Of course, if companies need to operate in Europe, they still need to be able to be competitive and make a profit. And also from the point of view of the citizens, it's not only having the clean and secure access to energy, but it's also to keep a job. And this should be actually the focus of the policies as well as attracting investments by the industry in Europe. So to reduce the CO2 emissions, we know that a few sectors have to contribute. We've been talking about transport, about buildings, industry, but one of the sectors which has to contribute the most is, of course, the power sector. And it has to do that through the renewables. And of course, these renewable technologies, they need to show that they can constantly have the cost coming down. And if you look at the cost structure of these technologies, and I just take the example of a battery cell because I'm coming from Umicore and we are a big producer of materials for battery cells, so we know the market quite well. You can see that 60% of the cost of a battery cell is the material. So if you want to reduce the cost of the battery cell, of course you can work on the other little pieces of the pie chart, but if you work on the cost, it's actually quite smart. So this is what you have to do. So increase the performance, reduce the cost, increase the lifetime. This is really the levers that you need to play with if you want to reduce the cost of these technologies. Of course, we are a big sector. Revenues is around 30 billion euro. It's around the GDP of Serbia. I think it's a bit more than a third of the GDP of Slovakia, so it's a sector important in Europe. But we see a few trends that need to be tackled. The first trend that we see is that developing countries know they invest more than developed countries in renewable energy. And I take the example of China. China has already overtaken Europe in terms of investment. As you can see, it's twice more last year than Europe. Per capita, it's around the same, but as a percentage of GDP, China invests now 4 times more than Europe. And I will spare you the details. Of course, you will have the slides, but if you look at the last pillar, you can see that in terms of renewable energy capacity today, China is 26%. It's an increase of 50% over the past couple of years. So this is actually a game changer. Trend number 2 is that, of course, still the same trend, sorry, is that in the next 5 years, the Europe risks being left behind in terms of investment in generating capacity. And as you can see, for the wind, for example, and for the solar, China is actually in the lead, still competing with Europe, but if you look at the situation in 5 years from now, China will be very well placed. For example, today, every hour, 2 wind turbines are installed in China. And it's not only about wind or about solar, it's also about electric vehicles. Today, the electric vehicle sales in China is 50% more than in Europe. And if you look at the plans of China, in their 5-year plan, actually, by 2020, it will be a 10-fold increase. Trend number 3, if the generating capacity is moving to China, part of the value chain is, of course, moving with that. And you can see that the manufacturing of devices and components is also moving to this growing market. So the consequence is that you start to see now Chinese companies which are leaders. And of course, what is the situation for Europe? We are replacing a dependency on fossil fuels by a dependency on technology. So we are replacing one problem by another one. This is the example, for example, for the wind turbines. You can see that now the first player is Chinese, and that in the top 10, top 15, actually half of them are Chinese companies. Same situation for PV. And the last important trend is that if you look at it from the point of view of research, you can see in for example, below, that actually Europe and China, for the first time last year, have been investing the same amount of money in R&D. The difference is that in China, most of the investment is coming from government R&D, and it's increasing. While if you look at the situation from Europe, actually most of the increase is very small, but it's still coming for industry, and 18% drop in investment by the public governments in R&D, in energy, renewable energy. So this is quite a challenge. Something has to change. So what is the impact? Well, of course, the impact is the job creation. As you can see from the first pillar on the left, the biggest job creation has been in China. 74% of the change has been in China. So 1.7 million jobs have been created in China over the past years in the field of renewable energy. Actually, in Europe, it's 3,000, so it's close to 0%. So if you look at the situation today, which is in the pillar in the middle, you can see that China, it's around 44% of the jobs. And if you add Japan, India, Taiwan, it's more than 55%. So there is a clear indication that Europe is not the only region of the world who is competing and investing in renewable energy, and something has to change. Of course, we can also have fun trying to look at whether a country is an exporter or an importer of technology. And as you can see, for every gigawatt of renewable energy, China is creating 10,000 jobs. Europe is creating 0 jobs, but if you take into account that it's because there's been a big shakeout in the PV industry, you could come to an average of 4,000. So we are still creating jobs, but compared to China, we are clearly importing technologies versus exporting technologies. So the impact is, of course, that we are losing leadership. Today, Europe is around 15% of the jobs in the field. A few years ago, it was 20%, so the trend is not a positive trend, and we need to do something about that. I will try to spare you the details, but one thing that I want to stress is that, of course, if you look at the value chain, you need to look at the different parts of the value chain. You have a downstream part, which we have been talking about, and you have an upstream part. And the upstream part is actually advanced materials. In the field of advanced materials, there hasn't been actually a destruction of jobs, but around 100,000 maybe jobs have been created over the past years. And if you look at the pie chart, the histogram on the right, you can see that actually from the 1 million jobs that we still have in renewable energy, around half of them are in advanced materials. So why? Because we are very strong in the field. And also because you don't move an industry of producing materials like that. And also because when you produce materials, you don't produce them only for renewable energy. So sometimes if there's a change in one market and there's another change in another market, they kind of cancel out. So there's still a reason to be present in Europe. But of course, if the markets are growing very much outside of Europe, you can expect that the whole supply chain is of course moving. We are in a European conference, so of course we have to look at the policies that we can use in order to mitigate these trends. And there are a couple of levers that we can use. I think that actually the 3 most important levers are those which are in red. The first one, it's European end market development. If our industry of materials doesn't have a market to provide something to, of course there's no reason to be in Europe, unless your cost position is still in a sense that you can still export. But of course, it's very difficult to export if you are not, if it doesn't make sense economically. The second pillar is a competitive, innovation-driven product offering. If you have a market, but you are not in a position to offer something to the market, then of course your competitor that may be outside of Europe will provide something. And the third point, it's a more general point, is the cost benefits and incentives of doing business in Europe. It could actually be possible to do business in Europe by not actually being established in Europe, but around Europe, you have the situation, for example, in the United States, where you can provide a lot of products to the United States by simply being established in Mexico. This is a trend that, of course, you see as well. I'm going to skip that one, but you will have it in the package. And in terms of action that we are actually promoting as an association, we are promoting the creation of an innovation pillar. As you can see, there are 3 policies that you can work on: the market, the innovation. Well, we are looking at the innovation now with DG Research, and of course we are looking at not a research pillar, because we have heard today that the value of death is very present, but you need to have your innovation pillar if you want to be able to bridge a gap. So in 2015 and 16, we've been working a lot with DG Research in order to list the priorities that should be supported from the financial point of view. In Europe, we are very good at making very long shopping lists, but actually at that time we had to make a priority. So this is what we have done with what we call an IDI, which is an industry-driven initiative. It's actually laying the blueprint that needs to be taken into account in order to have a bridge to this value of death. So we have an IDI, which has been promoted by EMIRI, but also by the Commission. It's around 20 topics. And of course, if you reach out to me, I can provide you with this document. And of course, they are in the TRL 4 to 7. We are very good at making basic research, but if we want to bring something to the market in a decent amount of time, we need, of course, to focus on where we can make a difference. The EMIRI IDI is actually typically built on 4 pillars. One is materials for the performance of buildings. A second is the materials for making renewable electricity technologies competitive. This is where you will find PV and wind. Another one is about enabling energy system integration. It's about storage. It's about materials for the grid. And the last one is about decarbonizing. There's another session actually in parallel about CCS and CCU, about using CO2. This is typically where you would find the materials that enable that. So if we do something about making sure that we focus, making sure that we have a right innovation policy, and if we have the markets, because if we have no markets, it's going to be difficult, we believe that we can make a difference. And we believe that if we cannot save the whole value chain, we can at least make sure that we maintain and reinforce the leadership of Europe in the field of materials. So if we do that, we'll be able to have the right materials faster to the market. If they go faster to the market, it means that LCE technologies, so low carbon energy technologies, will develop faster. It means that we will be able to make sure that our industry is competitive and sees a reason to continue being established in Europe, and maybe even serve other countries from Europe. This will secure R&D and capital investments. So that's I would say, the citizen part. And it will also make sure that we safeguard and create quality jobs for the people in Europe. So I'm going to quickly conclude, and I will maybe offer 1 minute to the next speaker. So I hope I was able to convince you that advanced materials are the key to the climate change, but we have to make sure that we don't always look the European way at the challenge. We also have to make sure that we look at it as an opportunity. And actually, this is a business opportunity. If we do something, we have the potential to create around 300,000 jobs in the field. So it's the moment to make sure that we innovate, and the moment to make sure that we make priorities. And I will leave the floor to the next speaker now.
Thank you, Fabrice, for this wonderful overview on EMIRI. And it's like a little bit frightening, no, that we're losing a little bit our competitive edge to China and other regions of the world, despite the fact that we really have a nice ecosystem for all those ground-laying research things. But at the end of the day, the manufacturing seems to be in China or elsewhere in creating the jobs, like in the solar or in other fields. So it's a pleasure now to introduce the next speaker, Professor Tiwari, who is the head of Laboratory of Thin Film Photovoltaics at the EMPA, the Swiss Federal Laboratories for Material and Science and Technology, and also adjunct professor at the famous ETH, the Swiss Federal Institute of Technology. And he's also chairman of the company Flisom, a startup SME company in Switzerland, which he founded together with his PhD students to transfer the world record efficiency technology on solar cells made on plastic film into manufacturing. So the floor is yours. Looking very much forward for your presentation on the viewpoint of a startup company. How did you bridge the valley of death? That's...
Well, thank you very much for kind introduction. First of all, I'd like to thank the organizers for inviting me and giving me the opportunity to talk about what work we are doing. And after speaking such a distinguished panel of speakers, sometimes very difficult what else to speak. You gave very nice, some very introductory talk, which has taken a lot of burden from me. So that's a good introduction to what I will be speaking about. And also Fabrice, you also spoke very nicely about some of the things which I'm not going to cover in my talk. Well, as you can imagine that as an academic, I can teach about the science. And coming from EMPA, which is a Swiss Federal Laboratory for Material Science and Technology, we are doing applied research for the benefit of industry and society. So it's a fairly applied research of industrial relevance. And then when I was at ETH, we were doing research on flexible CIGS, which stands for copper, indium, gallium selenide, thin film solar cells. And in 1998, we had a big breakthrough of developing 10% flexible CIGS solar cell, which was of the size of the fingertip or even less than that. On that fingertip size, we had about 5 or 6 solar cells. and at that time the conversion efficiency was 12%, and that was a big breakthrough. And in 2003, then we started realizing that this type of technology may have some benefits compared to the traditional technologies, and I'm going to talk about that. And then in 2005, when there was really peak of venture capital investment, especially in Silicon Valley, when they were really putting big money into photovoltaics. And the big money means not anything small. I'm talking about hundreds of millions. Yeah? So at that time, hundreds of millions of US dollar. And at that time, we thought, what's the point of doing this research if we don't try ourselves? So with that thought in mind, we established a Fleesome company together with PhD students and a business executive. And when we made a business plan, then it turned out that nobody is going to invest in this type of business if you are not showing a good return on the investment. And if your return on the investment is going to be about 10, 15, 20 years, then you have to choose the right type of investors. Okay? So when I was doing this type of analysis, then it became very clear that the VCs are not going to invest in our company. So that's the background of what I do, and now I will get into the specific topic. And I was asked, especially by the organizers, to address some of the challenges which one faces when you translate any technology from the research lab, which I mentioned, size of the fingertip, to industrial scale. So with that introduction, first I'd like to acknowledge that what I'm going to speak is not my own work, but this is the work of many, many people from my own lab. I can say roughly about more than 50 PhD students, postdocs, and scientists have contributed over the period of time for the development of CIGS solar cells in our lab. And also people from colleagues from Fleesome company, but we benefited a lot from European collaborative programs, especially supported through European funding agencies, as well as some funding programs from Swiss federal government. So after acknowledging this support, now I'm getting into the little bit of overview of various technologies. In the field of photovoltaics, you would hear many materials like silicon wafers and thin films, cadmium telluride or CIGS, and 3-5 semiconductors. So there are various technologies, and they have different level of maturities, and they offer different opportunities and also different level of challenges. But if we look from the market point of view, almost 90% of the market share is taken by crystalline or multi-crystalline silicon wafer-based technologies, which are fairly mature technologies, roughly more than 50 years, and there is a strong synergy coming from microelectronics. So when you have money and you have a good team, literally you can buy a manufacturing plant which will run within 6 months to full or 90% of the capacity. What you need is simply how to deploy it. So there is a very big level of maturity. More than 100 companies are working in this type of technologies. Many of them are in China, and you have heard about the success stories or the challenges put by those companies, how efficiently they have brought the cost of PV down, and how the industries in Europe and some other countries have affected because of the dominance of Chinese companies. On the other hand, thin film technologies, which are predominantly based on cadmium telluride and CIGS, they are very small, about 10% of the market share, but the market share or the production volume is continuously, especially production volume is continuously increasing, and they have certain distinct advantage. And if we look to the advantage, I'm not able to move it. Can you please move to the next slide? So the one advantage relates to the energy payback time, because sometimes money is not the only thing which you have to consider, because money can be calculated in a different manner depending on how you have access to the money. But very important is the energy payback time. And if one would compare the energy payback time, you are going to see the slide of thin film photovoltaics compared to the traditional silicon wafer-based technologies. These thin film PV technologies have shorter energy payback time. So this is a clear advantage when you compare a technology. Shorter energy payback time would mean a better and shorter time frame of getting profitability. So yeah, so but it doesn't matter. I think I can still speak about that. So when we are talking about, that new technologies and only 10% of the market share, it means either it is totally useless, because 90% is the majority, or there is a huge opportunity. And I'm going to show you, you also heard from the first talk, that how much energy can be generated from buildings or from transport. If you look to the roof of this room, you see this is steel, which provides you protection, and you can add photovoltaics and you can enhance the functionality of this. So there is so much what can be done in a better way with thin film photovoltaics, with light thin film photovoltaics, then which will be difficult from the traditional silicon wafer-based technologies. Now I'm going out of the scope of my slides, but I think it's better if I stop for a moment to get the slides. Otherwise, yeah. So in any case, when I say thin film photovoltaics, basically what I'm talking about is different from silicon wafers. These silicon wafers are about 300 micron thick, and what I'm talking about, thin film photovoltaics, these are thin coatings which are applied on any surface. It can be glass, or it can be plastic or metal foil. And these are about 4 to 5 layers of roughly half a micron or 1 micron. So in total, what we are talking about, 3 to 5 micron thickness coating applied on some surface. So to give you the context, human hair thickness is about 50 microns. So what we are talking about, 1/10 of the human hair thickness. So that's what I was talking about. If you look to the energy payback time of thin film solar cells, which is CIGS and cadmium telluride, and you compare to monocrystalline and multicrystalline silicon, despite lower efficiency, you have shorter energy payback time. So this is a very good reason to consider that thin film solar cells would be very useful. And especially CIGS, which stands for copper, indium, gallium selenide, it is important because it can be used very efficiently to give very high efficiencies. Roughly about 22.6% cell has been achieved in the lab, which is higher than the multicrystalline silicon wafer cell-based efficiency of the lab. And these coatings or these solar cells can be grown on metal, polymer, or glass substrates of large areas, few meters square. They look very black, beautiful, aesthetically very uniform, and they have low energy payback time, and eventually they can provide to low levelized cost of electricity, less than actually 5 euro cents, and they can also help to reduce the CO2 footprint in a significant manner. So if you want to get into the details informations about the CIGS solar cells and the potentials, there is a white paper where industries and the academia has contributed what can be achieved, and we also try to show that now is the right time to invest into this CIGS technology for commercialization. Here you see some of the examples that how nicely the CIGS solar cells grown on glass can be applied on buildings, and they can be also used for ground mount systems. And also what you see is an example of a flexible solar module, which would be the focus of my talk, and that's what we are doing. So Fleesum company is about roll-to-roll manufacturing of low-cost solar modules, which are lightweight and flexible. They offer new paradigm in PV, and it's coming because of the lightweight and flexibility, which allows you easy customization of shape, power, output, and adaptability to various applications. So beyond the lightweight and flexibility, also important is that these solar cells are highly efficient. So when it comes to the applications, this type of solar module, which you see, this is monolithically interconnected. It's grown on polymer film. The challenge was how to make such a high efficiency small cells and then translate on industrial scale on polymer films. And you can sandwich them on any back surface and on the front surface, and then you have the possibilities for various applications for portable electronics and portable power source for emergency response, and you can laminate them on aluminum or steel to use it for buildings as also retrofit. So there are tremendous opportunities in buildings, transport, and electronics. Only thing is that you have to know how you want to use them. And we have a European project called PV Site, which is focused towards investigation of that how one can use this type of flexible lightweight CIGS for building integrated photovoltaics. So as I indicated to you in the beginning, that the efficiency of 20.4% was achieved in the lab, which was the world record from our lab and which still holds. And this efficiency is quite high. But this efficiency is on a small area solar cell of 0.5 centimeter square. And then we had to make a monolithically interconnected module, and we were able to make with the laser patterning about 17% mini modules. So it showed that in principle the technology could be as efficient as multicrystalline silicon wafer technology to roll manufacturing. And then you go on the development phase, which takes many years. Equipment delivery time is typically 1 year. When you buy one equipment, pay to the vendor, you get an equipment after 1 year. So these were some of the challenges, that how you go in a phased manner. It's a huge risk when you go from a very small, teeny tiny solar cell to the dimensions which I showed you. You need very good investors who believe in the technology and who are open for innovation. So we were really very fortunate to have that type of investors. And now the company has two facilities. One is a 15 megawatt manufacturing plant, and which is based on 1 meter wide rolls. And the second is the development plant, which is based on 50 centimeter wide rolls. So now the company is at the verge of commercialization, entry to the market. And I was also asked to give certain recommendations based on what we have learned, especially in view of the support from the European Union and how things can help to translate from lab to industry. I'm not going to read all of them, but these are the recommendations which I'm going to leave on the screen, and I would like to thank you all for your attention.
Dear Professor Tiwari, thanks a lot for your speech, and obviously you managed to cross the valley of death and had a lot of support by investors to do so. First of all, I would like to thank all the distinguished speakers for their insights and sharing their results of research projects and initiatives. And I would like to open the floor for a couple of minutes, even if we are at the end of the session, for some questions. And I've seen there was one question from the auditorium. Some person seems to have a problem with the mobile phone. Hopefully not the battery fire. So if the person wants to specify that question a little bit more, otherwise I would maybe have one question for you. Your story was quite convincing, having the 15 megawatt production plant. So how can you secure now that a larger scale production can stay in Europe? Not that we lose this again or to other regions of the world, because then we would have not fulfilled our target to have more jobs and innovation spurring, Europe's prosperity. Does this work?
You see, when we got into this roll-to-roll manufacturing, one key important thing was to protect the knowledge so that it cannot be copied. And the difficulty which we had was about the IP. You see, almost 11 years have passed, and the IPs, the patents, they have a lifetime of 15, 20 years. If we would have had filed the patent at that time in the beginning, when the company was about to be formed, within soon the patents will run out. So one strategy was really to protect the IP and especially do it ourselves so that it's hard to copy. At some point, there would be people who would be able to copy it. Yeah. But then also we wanted to protect in a manner that we go step by step. Yeah? So 15 megawatt plant would certainly not be a very cost efficient plant. The next step is to go for 100 megawatt. And 100 megawatt, which we are talking about.
You will do this in Europe?
You see, in the end, PV is a global thing. Yeah. So our company, Fleesum, which is in Zurich, it will remain in Zurich. This was also a condition from our investors that the heart and the head has to be in Zurich. And then we are selling like a plant. It can be sold anywhere in the world, wherever it makes sense. But the company, the heart and the head will remain in Zurich.
Okay, thank you. Any other question from you? You can also use the micro if you like. Question on raw materials for wind and solar energies at high level in Europe. Maybe Fabrice is the...
Yeah, actually, if you look at what's
it's
happening
about raw
now,
material strategies for...
Yeah, so if you look today at what's happening in the field of raw materials, and if you look at the initiatives that are put forth by Europe, you must all be aware that there's a critical raw materials initiative coming from DG GROW. They have looked actually at a list of metals and other materials, raw materials I would say, and they have classified them in terms of supply risk and how important is it for the European economy. Out of that, they have listed, I think, 20 or a little bit more than 20 raw materials. And then now what is happening is that in terms, for example, of innovation and research, there are some actions about making sure that we reduce our reliance on these raw materials, whether by reducing the content in some applications, better by or by substituting them when it's possible. I think that substitution looks like a good idea, but it's very difficult to make. And then, of course, the recycling. And it's actually cheaper and even less CO2 producing to extract from scrap than to extract from the ground. So recycling is actually very well pushed by the Commission. And it's a way to use the concept of urban mining. So we're all sitting on a lot of scrap, metal scrap. And out of that, for example, if you take your mobile phone, you have 20 critical materials that are inside. So if we make sure that we have the whole collection chain and the whole supply to that collection chain and the recycling chain, then we can easily secure a supply of these materials.
So more circular economy type of approach.
Sorry?
Circular economy type of approach.
So this is the old debate around the circular economy. Huh? And of course, if some resources are in other countries, don't worry, if there's a market, these countries will sell the resources as well. They are not stupid.
Okay, thank you. Maybe a very last question before we close the panel of today due to the time. Maybe to all of you, I think you're all somehow involved in funding programs, FP7, Horizon 2020. And if you have 1 minute or 30 seconds with Commissioner Moedas, who's our Commissioner for Research and Innovation, to recommend something for the next framework program, this matches what you give him, very short if possible.
Thank you. I mean, in terms of, you mean a call or recommendations for the process?
Recommendation for the next framework program like Horizon 2030 or FP9, what can be done better, what is good today, but maybe what is your recommendation, what can be, because there's interim evaluation ongoing and at the Brussels bubble, a lot of people talk about already about recommendation for the next framework program. What would you tell him?
I think from our point of view, I think, again, listening to my colleagues, I think we need to pay attention to the speed at which we need to react. And sometimes we do things, but we take ages to react to them. By the time we react or we develop something, we realize that market or that technology has gone somewhere else. I mean, in our company now, we're focusing more on open innovation and to react with speed. And it's kind of a change in the mentality and perception. We're even encouraging people to try and fail. And if you fail, just make sure you fail with speed. So I think I've got experience with collaborative and work and European funded projects. Sometimes the process, the ideas are good and what have you, but the process takes too long. By the time you get there, it's irrelevant.
So you mean it's a different speed than the industry wants actually, right?
I think we're getting into, sorry, I'm taking time from my colleagues. I think we're getting now into a time where we need to react with speed. We no longer have, I mean, you can see now the mobile technology, I mean, they've gone down. They used to be developing something within 3-year cycle, now it's months. So innovation now has to react or be delivered with speed. And to do that, you cannot do that on your own. So you have to work in collaboration and framework and make sure we do things quickly. And as I said, if we fail, we fail, but make sure we, okay.
Any other opinion, any other voice? Maybe Fabrice?
I pretty much support that actually. If you look at innovation, the countries or the players that win are those which are fast and agile. So if we have a process that supports innovation, it has to be fast and agile. Otherwise, there's a mismatch between what you support and how you support it. So also, one comment that I'd like to make to Mr. Mudas, if he wanted to make me a Christmas gift, is make sure that you make priorities, because Europe is very bad at making priorities. We want to make everyone happy, but at the end of the day, we make everyone not happy. And if you focus on priorities, just make sure that you have evidence-based, because otherwise you just work with buzzwords and the fashion of the year. And that's something that we don't need in Europe. We need stability, and we need to be able to focus on something that makes sense in line with reality.
Yeah, also I'm aligned to that. The timing is very important. When we see to the call, sometimes the scope is very broad and it takes too long time. Industry is working with certain objectives, and if the timeline doesn't match, there's too much of paperwork. It doesn't help the industry to translate innovative ideas into production.
No, I share.
Okay, so I would like again to thank the speakers for their presentation and the discussion, and would like to thank you for your listening, even with 50 minutes overtime. I apologize for this. Also apologize for the little problem we had with the presentation. And let me wish you a nice conference, and hope you had a very good first day, and hope to see you tomorrow again. Have a nice evening. Ciao.